Welcome to qnawire.
So over here we're going to have the following reaction of nitrogen gas plus H2 gas to produce NH3. So the first thing that we need to do is to balance this reaction. We're going to add a 2 over here to account for the number of nitrogens. 2 times 3 is going to be equal 6. So we need 6 hydrogens on the other side, so we're going to require a 3 on this position. Now with this reaction, we're told that 12.1 grams of hydrogen reacts with 81.2 grams of nitrogen. We need to calculate what would be the volume of ammonium gas that can be produced at 19 degrees Celsius. So the first thing that we need to do is calculate the amount of mole of each of them. The amount of mole of hydrogen is going to be 12.1 grams divided by, in this case, 2 grams per mole. So 6.05 mole of hydrogen. And in the case of nitrogen, the amount of mole of N2 is going to be equal to 81.2 grams divided by 28 grams per mole, giving us 2.9 mole. Now, employing the stoichiometric relationships, what we can know is how much of each of the compounds is going to react with the other reagents. So, for example, in the case of nitrogen, we know that 1 mole of nitrogen reacts with 3 moles of H2. So, over here we would get 8.7 mole of hydrogen can react. Since this quantity, since this quantity is larger than the amount of hydrogen that we're going to have present, the hydrogen is going to be our limiting reagent. Now, since hydrogen is the limiting reagent, we're going to do the calculations on the amount of mole of NH3 that can be produced. We know that if we begin with 6.05 mole of hydrogen, 3 moles of hydrogen are going to react to produce 2 mole of NH3. Thus, we would be able to generate 4.33 periodic mole of NH3. Now, the question asks us to calculate the volume of ammonia gas that can be produced, which is already given by the amount of mole, at a temperature equal to 19 degrees Celsius and a pressure equal to 116.3 kilopascals, which is equal to 116,300 pascals. The temperature, we need to convert this into Kelvin by adding 273.15, and the resulting Kelvin is going to be 292.15 Kelvin. Remember that we need to do these conversions because our gas constant is in terms of kelvins. Now, actually the pressure we didn't need to convert it because we're given already the value for R in the appropriate units. That is going to be equal to 8.314 liter kilopascal divided by mole Kelvin. So now we can proceed with the ideal gas law. We know that Pp is equal to nRT. Thus the volume is going to be equal to nRT divided by by P, by the value for pressure. Replacing the values, we are going to get 4.333 periodic mole times our gas constant, that is 8.314 liter kilopascal. I'm going to write down mole to the minus 1, Kelvin to the minus 1, times my temperature, that is 292.15 Kelvin, divided by pressure, which is 116.3 kilopascals. Mole and mole to the minus 1 are going to cancel out. Kelvin minus 1 with Kelvin are going to cancel out, and kilopascal with kilopascal is going to cancel out. So the final answer is going to be given in liters and is equal to 90.5 liters of NH3. So that would be all. Thank you very much and have a good one.